Hello, welcome students. So today's topic is amines. It is the last part of organic chemistry. So in amines, we are going to discuss about nomenclature of amines. Next, classification of amines, how amines are classified, structure of amines and methods of preparation, physical and chemical properties, uses and identification of primary, secondary and tertiary amines. In this part, in today's class, introduction about amines, how amines are classified and their nomenclature. We will learn about this. So you know what is this? This is NH3, ammonia. This is ammonia. In ammonia, each nitrogen atom is attached with 3 hydrogens, NH3. Ammonia, NH3. So what are amines? Amines means the derivatives of ammonia. That means instead of H, you can write R, H. This R is a alkyl group. If second H is also replaced with R, then it is also called amine. 2 R's are there here. Third H also is replaced with R, then it becomes R. So derivatives, organic derivatives of ammonia are called amines. That means amines can be considered as derivatives of ammonia obtained by replacement of 1 or 2 or 3, all the 3 hydrogen atoms by alkyl or aryl groups. This NH3 ammonia, in NH3 1H is replaced with methyl, so it is one amine. Here aryl C6H5NH aryl. Here only NH is there, that means 2 alkyl groups. Here only N is there, 3 hydrogens are replaced, 3 hydrogens. So amines can be considered as derivatives of ammonia obtained by replacement of 1 hydrogen like this, or 2 or all the 3 hydrogen atoms. Here 2 hydrogens replaced, here 3 hydrogens replaced. These are called amines. So amines in everyday life. In nature, they occur among proteins, vitamins, alkaloids, and hormones. You can see some examples. This peptide bond is there. CONH bond. CONH bond is called peptide bond. So this peptide bond compound is called protein. Protein contains NH. Vitamins. It is one type of B vitamin. Vitamin B1, it contains NH2, means amine. Next, third one, alkaloid, nicotine. This one also contains N amine. Next one, hormones, thyroxine. Thyroxine contains NH2. It is also called amine. So these are the amines in everyday life. Proteins, vitamins, alkaloids, and hormones. Some other amines we are using in everyday life, we will see. Synthetic examples including polymers, dyestuffs, and dyes. 2 biologically active compounds, namely adrenaline and ephedrine, both containing secondary amine group and used to increase blood pressure. Novocaine, a synthetic amino compound, is used as an anesthetic in a dentistry. Anesthetic, anesthetic. Benadryl, a well-known antihistamine drug, also contains tertiary amine group. Quaternary ammonium salts are used as surfactants. This is very, very important. Diazonium salts are intermediates in the preparation of variety of aromatic compounds, including dyes. So these are some compounds we are using in everyday life, which contains amines, polymers, dyestuffs, dyes, adrenaline, and enzymes. Next, anesthetic drugs, Benadryl, and benzene diazonium chloride, diazonium salts. Next, structure of amines. Structure of amines. You can say this is the structure of ammonia. Shape ammonia, NH3. It is lone pair, unshaded electron pair. If it is NH3 ammonia, 3 atoms are hydrogen atoms, and this is lone pair of electron. This is ammonia. But here, instead of this H, CH3 group is there. Instead of H, CH3 is there. Alkyl groups are there. That means it is amine. But both are having same geometry, that is pyramidal. Pyramidal. Both are having pyramidal geometry. Here hybridization is sp3. Hybridization of nitrogen is sp3 hybridization. sp3. Like ammonia, nitrogen atom of amines is trivalent, means it has 3 bonds and carries lone pair of electrons. Nitrogen orbitals in amines are sp3 hybridized and the geometry of amines is pyramidal. Due to the lone pair of electrons repulsions, due to the repulsions between this lone pair and bond pair, the angle is less than 109 degrees, 109.5 degrees. Actually, because of sp3 hybridization, tetrahedral angle is 109 degrees, 28 minutes. Because of these repulsions, it is reduced to nearly 108 degrees in case of trimethyl amine. So bond angle is less because of repulsions. Classification of amines. This is ammonia. In ammonia, if only one H is replaced with alkyl group, only one H, this H is replaced, then that amines formed are called primary amines. Primary. If 2H are replaced with alkyl groups, R, alkyl, this is also R. It is secondary. In ammonia, only one H is replaced. So the remaining thing is RNH2. Here 2 are replaced, R2NH. Here 3 alkyl groups came. That means 3 H are replaced. So this formula, general formula is R3N. R3N. What is the general formula of tertiary amines? R3N. Secondary amines R2NH. Here RNH2. So amines are classified into 3 types: primary, secondary, and tertiary amines. Amines are classified as primary amines, secondary amines, and tertiary amines depending upon the number of hydrogen atoms replaced by either alkyl group or aryl group in ammonia. Alkyl group means, example, CH3 methyl, C2H5 ethyl. These are alkyl groups. Aryl groups means C6H5 aryl. These are called aryl groups. Amines are said to be simple when the alkyl groups or aryl groups are same. Both sides, this R and this are same. Then the type of amines are called simple amines. simple amines are symmetrical. Symmetrical. If both alkyl groups, here you can see one is R, another one is R dash. Both are different. When they are different, the amines are called mixed amines. Mixed amines are unsymmetrical. Amines based on alkyl groups classified into simple amines and mixed amines. So next important step is nomenclature of amines. Nomenclature of amines. There are two types of nomenclature systems. One is common system and IUPAC system. For example, I will take CH3NS2. It is an amine. CH3CS2NS2. It is another amine. So in common system, this group, methyl amine. Here, two methyl groups are there. I'm sorry, ethyl group. So its name is ethyl amine. CH3NH, methyl. So its name dimethyl amine. So in general, common name means alkyl amine. This is about common names of amines, alkyl amines. You will see next IUPAC names. For the same compound, root word, how many carbons are there? One carbon. So meth, single bond, ane. In methane, this E, you replace this E and add amine. So complete name is methanamine. No gap, there is no gap, methanamine. Here two carbons in chain, root word is ethane. Here NH2 is functional group, ethanamine. Here NH is there, so only one carbon is there in chain, methanamine. But this CH3 is you are taken as substituent. This one will come as prefix methyl methanamine. This methyl is linked with N-methyl methanamine. So these systems we will discuss in detailed manner. So nomenclature of amines. First of all, in common system, aliphatic amine. In common system, aliphatic amine is named by prefixing alkyl group in alphabetical order to amine. That means like alkyl amine as one word. Example, methyl amine. This methyl is alkyl amine. CH3NS2 name is methyl amine. What is C2H5NS2? C2H5NS2 is ethyl amine. This is in primary amines. But in secondary and tertiary amines, when two or more groups are there, are the same, two methyl groups are there, then prefix di will come. Three methyl groups are there, tri will come. In secondary and tertiary amines, when two or more groups are the same, the prefix di or tri is used before the name of alkyl group. For example, you can see here CH3, NH, CH3. Methyl. So what is alkyl group? Methyl. So two are there, dimethyl amine. One more example, N, CH3. Three methyl groups are there, so trimethyl amine. Next, nomenclature of amines in IUPAC system. In IUPAC system, primary amines are named as alkanamine. So based on root word alkane, because it is a amine, while joining this amine, you have to replace this E. Instead of this E, name is alkanamine. Alkanamine. E of alkane is replaced by amine. For example, CH3NH2 named IUPAC name is methane plus amine, so methanamine. Methanamine. To name secondary and tertiary amines, we use locate N. Actually, 1, 2, 3. Instead of 1, 2, 3 numbers, we are using the symbol N to designate the smaller substituent attached to a nitrogen atom. You will see some examples here in IUPAC system. CH3 NH C2H5. So here, this one I have taken as chain. So 2 carbons are there, ethane, ethanamine power. But this small group CH3 is attached to nitrogen. So N-methyl ethanamine. N-methyl ethanamine. One more CH3, CH3, CH3. What type of amine this one? 3 alkyl groups are there. It is a tertiary amine. Tertiary amine. So this is the chain. Only 1 carbon is there. Methanamine. 2 methyl groups are there. So dimethyl, methanamine. 2 are attached with nitrogen. So that's why you have to write NN dimethyl methanamine. These are the IUPAC names. For the same compound, common name is amine. Common name amine ends with amine. One is methyl, another one is ethyl. You have to write alphabetical order. Ethyl, methyl, amine. Here, 3 methyls are there. Trimethyl amine. Once again, what is the general name in common system? Alkyl amine. What is the general name in IUPAC system? Alkanamine. Alkanamine. You will see some examples here. CH3CH2NH2. Common name. This group is ethyl. Ethylamine. This group is propyl. That too chain. N-propylamine. This is also propyl, but this propyl is isopropyl. Isopropylamine. This is a secondary amine. And you have to check first of all, you will check what type of amines these are. Amines, what type of amines? First one, NH2 means primary. It is secondary. It is tertiary. Only N is there. Tertiary. Primary. It is a diamine. Primary amine, diamine. So here 3 carbons are there. It is iso group, isopropyl amine. Here secondary amine. One is methyl, another one is ethyl. Alphabetical order you have to write. Ethyl, methyl, amine. 3 methyls are there. So trimethyl amine. Ethyl, 2 ethyls, and one is butyl. 2 ethyls is there. That's why diethyl, butyl amine. This is prop in IUPAC system. In common system, it is called allyl amine. This is hexamethylene diamine. This one will come in the polymers chapter also. Hexamethylene diamine. So you'll see next IUPAC names. Number of carbons are 2. So ethane amine. Number of carbons are 3. propane amine. Amine is at first carbon. 3 carbons, propane, 2 amine. This is chain with the 2 carbons. So ethanamine. This N is attached with 1 methyl. So N-methyl ethanamine. So this is NN dimethyl methanamine. So here is there. You can check other names also. So this is about IUPAC names. In aryl amines, next, in aryl amines means NH2 group is directly attached to benzene ring. These are called aryl amines. For example, C6H5NH2. In C6H5NH2, NH2 is attached with benzene ring. It is the simplest example of aryl amine. This aryl amine, in common system, it is known as aniline. It is also accepted IUPAC name. C6H5NH2, its name is aniline. While naming aryl amines, according to IUPAC system, suffix E of irine is replaced by amine. For example, C6H5NH2 you take benzene. In benzene, E is replaced with amine, so its name is benzenamine. What about aryl amines? In this slide, we discussed about aryl amines. In aryl amines, NH2 is attached with the ring, benzene ring. These are called aryl amines. Particularly, this compound is also called aniline. Aniline is common name as well as IUPAC name also. What is another name of aniline? Benzenamine. Here, some examples for aryl amines. This is aniline, common name. Aniline or benzenamine is IUPAC name. This is, only CH3 is there, toluene, but only NH2 is there, aniline. So ortho position CH3 is there, then this is called orthotoluidine. What is the name? Orthotoluidine. Up to this, it is aniline. In para position, Br is there, para-bromo-aniline. What about IUPAC name? 1, 2, 3, 4. So 4-bromo-benzenamine or 4-bromo-aniline. This compound is aniline, is the main compound. 2 CH3s are there. So N, N dimethyl aniline. NN dimethyl aniline. So NN dimethyl benzenamine is the IUPAC name. So some more examples of nomenclature of amines. You can see here it is a diamine. First example, 1, 2, 3, 4, 5 carbons are there. So pentane is the root word. 2 NH2s are there at second and third carbons. So pentane 2,3-diamine. The letter E of the hydrocarbon part is retained here as it is followed by a consonant. So pentane 2,3-diamine. Next one. 1, 2, 3, 4, 5. 5 carbons. Is a chain. At second carbon, this N is attached. So pentane 2-amine. For this amine, one ethyl group is there, one methyl group is there. So alphabetical order, N-ethyl, N-methyl, pentane, 2-amine. N-ethyl, N-methyl, pentane, 2-amine. This is aniline or benzene amine. At fourth position, Br is there. At second position, ethyl is there, C2H5. So 4-bromo, 2-ethyl benzene amine. Next one, it is a tertiary amine, methanamine. 2 methyl groups are there, NN dimethyl methanamine. This is 6 carbons, hexane. At first position, at sixth position, 2 are there, hexane 1,6 diamine. Hexane 1,6 diamine. So try to find out the names for these compounds. So first one, it is like aniline or benzene amine. So aniline. This is methyl, this is methyl. So 2 methyls are there, N comma N dimethyl aniline. What about this one, next compound? This is 1, 2, 3, 4. Fourth carbon is there. Fourth carbon and NH2 is there. Fourth carbon and NH2. 1, 2, 3, 4. 4 carbons. 1, 2, 3, 4. 4 carbons. At 2, phenyl amine. At 1 amine. 1 amine. Butane, 1 amine. At second, phenyl. Here, this one is taken as parent chain. Butanamine, 1 butanamine. At second position, phenyl. At second position, phenyl. Next, this is what type of amine? This first compound. First of all, you check amines. What type of amines? Here N is there, tertiary. Here NH2 is there, primary. Here N is there, tertiary. Here NH2 is there, NH2 is there. It is a diamine, primary amine. Now, what is the IUPAC name for third compound? Ring. It is attached with ring means it is aniline only. Aniline. Substituent. Methyl is there, ethyl is there. Alphabetical order. N-ethyl, N-methyl, aniline. What about this ethane? Ethane, diamine. Ethane 1, 2 diamine. So these are some examples. Now some in-text questions. It is in-text question 13.1 from our textbook. Classify the following amines as primary, secondary, or tertiary. Just a classification. Which type of amine? This one. It is easy. I told already. NH2. Here only N. Here NH2. Here NH. If it is NH2, that amine is primary. Only N, tertiary. NH2, primary. NH, secondary. Secondary. So next question, 13.2. Write structures of different isomeric amines corresponding to the formula C4H11N. So you know what is the general formula of amines? General formula of amines is CnH2n plus 3n. With this formula, 3 types of amines are possible. Primary amines possible, secondary possible, tertiary also possible. With this formula, total 8 isomers are possible. 8 isomers, 8 structural isomers are possible. First of all, you will see it is a primary amine, NH2, 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 NH2. How many primary amines are there? 4 primary amines are possible. 4 primary amines are possible. Out of total 8, 4 primary. NH, NH, NH. Secondary. 3 secondary amines are possible. Only N is there. It is a tertiary amine. So total with C4H11N, how many isomers possible? 8. 4 plus 3 plus 1. 4 primary amines, 3 secondary amines, and 1 tertiary amine. In this answer, all IUPAC